pituitary gland has a brightly stained portion. Look at that. Has a brightly stained portion. That portion there. That's the adrenal hypophysis. Brightly stained part. So you can see this even with your naked eye. All of this area here, brightly stained part, that's the adrenal hypophysis. And then you also observe a pale portion, which is this portion here. That's the pars posterior or the posterior lobe. Pars nervosa, sometimes it's called. So grossly, therefore, you're going to see two parts. You're going to see a pars distalis, that's what we sometimes call the anterior lobe. It's very colorful, this part here. And then we're going to see a paler portion, that's the pars nervosa. Observe a small area between the two. If you look on the screen, you'll notice this little area here with some follicular looking structures. This would be the pars intermedia. Pars intermedia. In man, the pars intermedia is not well developed. Well developed in lower reptiles and so on, but not in man. So yes, you should be aware of its existence and the function of what is produced by it. But by and large, the two most important parts would be the pars distalis, which is this part here, and then the pars nervosa, which is that part. I also want you to observe that this slide we're looking at now is the H and E stained pituitary, hematoxylin and eosin. So I'll be showing you two pituitaries. This is just one of them. I want you to observe too that this pituitary gland is invested in a well-developed capsule. That's the pale portion there. That's a well-developed capsule. Now if you recall where the pituitary gland is situated, you'll have an idea of what forms the capsule. So the pituitary is located in the middle cranial fossa, just where the sella turcica is. It's located in that middle cranial fossa, and it therefore means that the dura mater of the middle cranial fossa is what forms the capsule of the pituitary gland, the dura mater. Dura mater. So what it means, therefore, the same nerve that provides general sensory fibers to the dura mater in the middle cranial fossa. That same nerve is providing sensation to the capsule of the pituitary gland. And that nerve is the nervus spinosus. That nerve is actually the meningeal branch of the mandibular nerve. It is also called the nervus spinosus. Just to remind you, this nervus spinosus gets there by traveling through the foramen spinosum. Foramen spinosum of the mandibular nerve. Meningeal branch of the mandibular nerve. Alright, now also note the preponderance of these pinkish areas. These areas represent capillaries. And so now you understand and you appreciate that the pituitary being an endocrine organ will be very vascular. These capillaries are fenestrated. So these are fenestrated capillaries. So the pituitary gland is highly vascular due to these numerous capillaries, and these capillaries are fenestrated. Now, when you observe the parenchyma of the pituitary gland, you will notice that the cells are organized into clumps, into clusters. Each cluster being surrounded by a fine little strand of connective tissue. And so these clusters are sometimes described as cords, C-O-R-D-S, cords. so what we have observed is that most of the endocrine organs have their cells, their functional cells, these parenchyma cells, organized in the same way, cords. The only endocrine organ that's not organized like that is the thyroid. All the others are organized with the cords. And these cords are surrounded by little strands of connective tissue. And look, juxtaposed right beside the cord, look at this. A lot of capillaries there with RBCs. So these cords are highly vascular. So we have said some good things. We have talked about the fact that the pituitary is divided into an anterior and a posterior lobe, with sometimes an intermediate lobe between the two. We've also observed too that it has an investment of dura mater as the capsule. And now we're talking about the arrangement of the cells of the anterior lobe being organized into clusters. Now let us take a more detailed view of these cells, these cords of cells. And I want you to observe that the cords have some beautifully colored cells. Some cells have brilliant pink cytoplasm, whereas others, the cytoplasm is not so brilliant. And it seems as if there is a third group where there doesn't seem to be much cytoplasm at all. So now, we have to tell you that the anterior lobe, these cells are three kinds of cells. And let me just navigate my way through so I can find some beside each other. So there are three kinds of cells in the anterior pituitary. We have, well, first of all, we divide them grossly into two groups. Chromophils and chromophobes. Chromophils and chromophobes. And you will appreciate from those two words that the chromophils are the ones that are taking up the stain. So these are the ones that are staining brilliant, like this one here. So the chromophils are the ones with bright, nice, beautiful cytoplasm here. Those are the chromophils. Can you see that? Now on the other hand, there are some that don't seem to show much cytoplasm at all. For example, if you look at these ones right there, all these features are nucleus. See that? Those are chromophobes. So we grossly have chromophils and chromophobes. Now the chromophobes are reputed to be stem cells. These chromophobes are stem cells, precursor cells. They give rise to other chromophils. So those are the chromophobes. Now, although these chromophobes appear to have no cytoplasm, that is obviously not true. They just have scanty cytoplasm. The cytoplasm is not as abundant as the others. Alright, so these chromophobes now are giving rise to the chromophils. Let us revisit these chromophils, because with H and E, it's not very easy now to differentiate between the acidophils and basophils. So these chromophils are further divided into acidophils and basophils. And I want you to pay attention and see if you can identify these two cell types. We got these two right beside each other, for example. I'm pointing at two cells right beside each other. You have to agree that the one above, so let me put a point on that one, you'll have to agree that this one here, well, the one, you'll have to agree that the one below, that one being pointed at, the cytoplasm looks a shade darker. You see that? That's the basophil. Cytoplasm is just a shade darker. So you don't have to be observant. That's one of the key things about this faculty. You have to be observant, or else you're going to kill your patients. So that's a basophil. Now just next door, this one here now, that's the what? That's the acidophil. And you see that the cytoplasm is just a little bit brighter. Good. So you can identify and differentiate the two cells, these two beautiful cells with the H and D. Acidophils, brighter cytoplasm, basophils, cytoplasm slightly darker.